So here is your equation to number one. They want you to relate the radius and the area together, and most importantly, the rates of change of their area to the radius. So let's take the derivative of this equation. Obviously, the left side will become dA dt equal to, now remember, this is pi times r squared. So pi is a coefficient. So nothing happens to this coefficient, okay? It just remains there because it's actually a representation of a number. And then we take the derivative of 2r, and so r squared, I'm sorry, so you get 2r, but we also have to write what? Times dr dt. Why are we doing this? Again, to summarize, we're taking the derivative with respect to time, and there isn't time in any of this equation. So that means we have to show the relationship of the derivative in the actual derivative process. It's not just simply saying derivative of a is 1 and derivative of 2r is just, r squared is just 2r. So now we actually have rates of change that are associated with each other in this formula. And that's all we're doing here. Answer to this. What is the derivative of s equal to 4 pi r squared that relates ds dt to dr dt?
ds over dt equal 4 pi
4 pi
parentheses 2r times dr dt.
Correct, Ian. And see that? Look, just last week you were like, this doesn't make sense. And now guess what?
This makes sense.
You just did it. You were correct. You're absolutely correct. You knew what you had to do. Because again, right here, we don't have time in this whole equation. So the variables that we are taking derivatives of, we have to show their derivative expressions next to them. Okay, so obviously there would be a 1 right here, but I don't have to worry about it. You already knew right away. 1 times ds dt is just ds dt, so you don't have to write that down. That's very good, Ian. Now, can anyone tell me, can we simplify this equation any further, or do we just leave it like that?
You can simplify.
Yes, we can simplify. How?
Would you distribute the 4?
The 4 to what?
To the inside the parentheses?
That's right. To what other number?
To the 2?
That's correct. So then I end up with what?
8.
Can you tell me the rest of it, Adon?
8r.
8r? I think I'm missing something. Can someone help out? What am I missing between?
Pi r.
Thank you. All right, don't forget that part. Right. Pi r, and then what? Dr dt. Very good. Very good. Okay, and so this would be my final expression there, because we can go ahead, like Adon said, we can distribute this, right? Either way you look at it, either distribute both ways, we can distribute it and make it to one simpler coefficient term. All right, I'm going to go ahead and pause again. All right, guys, so before we move on, let me go ahead and move this up a little bit. It should be good. Okay, guys, so on number 3, how is dv dt related to dr dt if h is constant? I'd like to hear someone's, I guess, final answer on this. What their suggestion is. Like, what am I going to have at least on the left side, like here? So I'm going to have dv dt. Now, if you're gonna remember, guys, if you're gonna speak, make sure you don't unmute yourself too quickly, because then you won't have a chance to like say anything. So dv/dt on one side, we're gonna hold h constant. So what would we actually only take the derivative of?
The radius.
Correct. So what would my derivative be there? That's correct, April. So to basically sort of rearrange this, it'll be 2 pi r times dr dt, then times h. Because h is held constant. I'm not going to do anything about it. That's what I mean by constant. So that means I'm going to replace h with a number, and it'll just look like another coefficient being multiplied to 2 and to pi. And that's it. So this is what they mean by holding it constant. Nothing happens to this, okay? So let me erase this part, write it in red instead. Times dr dt. So that's what I have there. So that is my derivative holding h constant. So by that logic, if I go to number 4, what would the derivative of the volume look like if I hold r constant now? Left side would be what again, guys?
dv over dt.
Right, so we know that much, dv dt, because we have to have that. And now this time we're going to only differentiate the h. We leave the r alone. So what is that going to look like? Right, we're going to have pi r squared. And then let's see what someone else says here. That's right. And then we're just going to have dh dt. Correct, afterward. Very good. That's it. So that's that expression if we had r as a constant instead of h. So now for the final question of the day. How is dv dt related to dr dt and dh dt if neither r nor h is constant? So I'll leave you guys a moment to do that. If you haven't, I'm going to go and. So guys, what does my particle look like? Someone can start off telling me like what they chose as their first, what they took derivative of first versus the second derivative. I mean, the second function took a derivative of.
would it start off as 2RH times dr over dt?
Okay, 2RH times dr dt. That's correct. So you took the rid of r first, you left h alone. Okay, let me go ahead and write this in black. All right, so h was left alone. Then the next part, starting off where Sarah just started off with that. Now, what will the next one look like?
It would be r squared times dh over dt.
That's correct. Thanks, Sarah, for helping Sarah out. So again, this is just product rule. She took the derivative of r squared first, so she decided to call this one her maybe like f of x or f function, and then this guy was her g, and just went with this. The product rule would be f prime times g plus g prime times f times g prime. So the pi is right out here because that was just the coefficient constant. And so now we can kind of clean this up a little bit, but honestly, we can just basically leave it like this now because we got nothing to combine like terms. So we leave it like this so we know exactly what you have. Okay? So now again, we're just practicing with writing the relationships of the functions. Okay? In related rates. Tomorrow, we will go ahead and take a look at a free response question style, and we'll see exactly, again, the same type of format, and then now we'll actually solve a problem with application. I'm going to go ahead and stop